Welcome back to another episode of Science Unveiled. Today, we're diving into a force that's all around us and plays a crucial role in our daily lives: frictional forces. So, buckle up because we're about to explore the fascinating world of friction. What is friction? Friction is the force that resists the relative motion of solid surfaces, fluid layers, and material elements sliding against each other. Whenever two surfaces come into contact and try to move relative to one another, friction steps in. Friction opposes the direction of motion or attempted motion. Frictional forces act parallel to the surfaces and oppose the direction of motion. The magnitude of the frictional force depends on the nature of the surfaces in contact, specifically their texture. Rough surfaces with more irregularities tend to create higher friction due to increased interlocking of surface asperities, while smooth surfaces generate less friction. But did you know there are different types of friction? Let's break them down. 1. Static friction. This is the force that prevents stationary objects from starting to move. Imagine trying to push a heavy box that's not budging. That's static friction at work. 2. Kinetic friction. Once the object starts moving, kinetic friction takes over. It opposes the motion of objects already in motion. 3. Rolling friction. Ever noticed how rolling a ball is easier than sliding a book? That's because rolling friction is the resistance experienced by a rolling object. 4. Fluid friction. When objects move through fluids, like water or air, they experience fluid friction. Swimmers and planes know this all too well. Let's talk about a special type of fluid friction called drag, specifically air resistance. Drag acts on objects moving through a fluid medium, like this model airplane through the air. Drag and air resistance increase with the speed of the object and the cross-sectional area facing the direction of motion. They play a significant role in the design of vehicles, aircraft, and sports equipment. Despite its resistance, friction has some major perks. It enables walking and movement. Without friction between our feet and the ground, we'd be slipping all over the place. 2. Vehicle traction. Friction between tires and the road lets vehicles accelerate, brake, and turn safely. 3. Writing and drawing. Friction between your pencil and paper makes writing possible. 4. Grip and handling. Friction lets us hold and manipulate objects securely. 5. Heat generation. Rubbing sticks together to start a fire. That's friction in action. But friction isn't always our friend. It has its downsides too. 1. Energy loss and excessive heat. Friction converts kinetic energy into heat, reducing efficiency in machines. Excessive heat can damage machinery. 2. Wear and tear. Over time, friction wears down mechanical parts. 3. Reduced speed. Friction slows down moving objects, requiring more energy to maintain motion. 5. Noise production. Friction can cause unwanted noise in mechanical systems. Friction is essential in many practical applications. 1. Brakes. Friction slows down or stops vehicles. 2. Matches. The friction between the match head and the striking surface ignites the match. 3. Tires. Specially designed treads increase friction for better road grip. 4. Sandpaper. Abrasive particles create friction for smoothing surfaces. 5. Climbing. Friction between hands, feet, and surfaces enables rock climbing. Sometimes, we need to reduce or stop friction. Here are some thoughts. 1. Lubrication. Adding lubricants like oil or grease reduces friction. 2. Smoothing surfaces. Polished surfaces decrease friction. 3. Using rollers or ball bearings. These convert sliding friction into rolling friction, which is generally lower. 4. Air cushions. Creating a layer of air between surfaces, like in air hockey tables. 5. Magnetic levitation. Using magnetic fields to eliminate contact between surfaces. 6. A streamlined body design reduces drag or air resistance by minimizing the disturbance of airflow around the object. This is achieved through specific contouring that promotes smooth, laminar airflow and reduces turbulent flow, which is a major source of drag. To achieve streamlining, the forward part of the object should be well-rounded, and the body should gradually curve back to a tapering rear section, resembling a horizontally inclined teardrop shape. This design minimizes the turbulent wake and thus reduces drag. Streamlined shapes are used in various applications, such as airplanes, cars, and boats to enhance speed, reduce fuel consumption, and improve maneuverability by presenting minimal resistance to air or water flow. Frictional forces are an essential part of our physical world. While they can be beneficial in many situations, they also present challenges in others. Understanding and manipulating friction is crucial in engineering, physics, and everyday life. By carefully managing frictional forces, we can improve efficiency, reduce wear, and optimize the performance of various systems and devices. Thanks for watching. Don't forget to like and subscribe for more Science Explainer videos. See you next time.